So now we have a question in the face like an Lagrange equation. So what we have is x squared p plus y squared q plus z squared equals to 0. So we can just simply write it in this form: x squared p plus y squared q equals to minus z squared. So this is in this form, p then q equals to z or r. So this is in this form, so it's like Lagrange equation, so we can actually solve this easy. So what we have to do is just write it, the auxiliary equation, and the auxiliary equation is always going to be in the form dx p equals to dy q equals to dz r. So that's always to write in this kind of question, we just write it in this form. So what we have to do is, what is the coefficient of p here? This is our p. Let me change the color. This is our p. This is our p, q, and r. So let's substitute that into this. We have what? dz is x squared equals to the y is y squared equals to dz is minus z squared. So now what we can do is we can compare now. So that means we can write dx equals to x squared and the y equals to y squared. Now they are already separated, so we can just integrate straight away. So when we integrate this now, we integrate 1 over x squared, so it's going to give us minus 2 plus 1 over minus 2 plus 1 equals to y is minus 2 plus 1 over minus 2 plus 1 plus c1. So when we integrate this is going to give us minus 1 over x equals to minus 1 over y plus c1. So when you take y to the other side, equals to 1 over y minus 1 over x equals to c1. We take note of this. The next one is to integrate the other two numbers. So we have the y equals to y squared equals to the z equals to minus z squared. So we also integrate this form also because they're already separated. So that means y minus 2 plus 1 over minus 2 plus 1 equals to z minus 2 plus 1 minus 2 plus 1 plus c2. For this constant, this is going to be minus 1 over y equals to minus 1 over z plus c2. So this is going to be 1 over z minus 1 over y equals to c2. So the solution for this has been, the general solution of equation in this Lagrange form is going to be this. We'll write it as phi equals to c1 comma c2 equals to 0. And what's our c1 in this case? Our c1, we got y minus x. So this is our c1, y 1 over y minus 1 over x, and our c2 is 1. So let's write it. So the general solution is going to be now is 3. Then what is our c1? That is 1 over y minus 1 over x comma 1 over z minus 1 over y equals to 0. So this is our final answer for this. So let's take another question. In example 2, we have p plus q equals to sine x. So it's in the form, still in the form p of p equals to q of q, then r of r, yes, in this case of r. So this is our p. What is coefficient of p is 1, so that is our big P, capital P, and this other uppercase q is also 1. So this is still in the form Lagrange form. So we can solve it that way. So our dx is coefficient of p equals to our dy, which is still 1, then our dz is sine x. So what we can actually do is what we can integrate, we can just bring out our dx and y, compare them, since so 1 equals to dy over 1. So what do? We cross multiply. Oh yeah, so it's still 1, so the x equals to dy. What we just have to do is integrate. When we integrate, we are going to get x equals to y plus c1. So when we integrate, so just x minus y equals to c1, and that's our first answer. We take note of this. Then the second part we have is, so we're going to use z. We are going to use the delta x because we have x here, x in this form, so we still have to substitute. So let's just take it that way. So equals to dx over 1 equals to dz sine x. So what do you just do? So that means if we cross multiply, this means that this is sine x dx equals to what? Dz. So when you actually integrate, you're going to get minus cos x dx, and when you integrate this, you're going to get z plus c2. So if you take it, this is going to become minus cos x. I'm still writing dx, no, the minus z equals to c2. So the general solution for this equation, solution is going to become 5s. Then what's our c1? We got x minus 1, comma, then we are going to have minus cos x minus z equals to 0. So that's all for today. Don't forget